let's now implement the Fibonacci sequence method. Now in this case, we take as an input an array of integers, and then we want to determine whether or not they represent part of they represent a Fibonacci sequence, which means let's say, for example, if IA the length would be the first IA the length elements in the Fibonacci sequence. For example, let's have a look. So now, again, let's review. As we discussed in the previous method, we say that this is what a Fibonacci sequence is. Okay, so now we got the first two elements are always 1, and then starting from the third element, you simply calculate the sum of the previous two elements to get the next one. Okay, that's what we learned from the previous method. So now, let's now see if the various example over here are Fibonacci sequence. And basically, to be a Fibonacci sequence, these are the conditions. Okay, so the first elements for the first elements must be 1, and the second elements must be 1, and also starting from the third elements, it must be the sum of, for all the elements starting from the third one, it must be the sum of the previous two elements. For example, 3 over here is the sum of 2 and 1, right? Similarly, 5 over here is the sum of 3 and also 2, right? That's how we calculate it. Okay, so now it's again similar to the for all problem that we have seen so far. The all multiples of 5 and also is arithmetic sequence, very similar, right? So now the details are not exactly the same, but abstractly speaking, they are really the same problem. So we want to somehow to accumulate certain result to make sure for all the elements we are seeing in the iteration, they satisfy certain property. Okay, so now let's see what we have. So now for this kind of problem over here, we say that as long as you cannot find out any violation witness to prove that the property is violated, it's going to return true. Okay, so now in this case, so now in the case of let's say IA1 being empty array is trivial because you definitely cannot find any element being the witness in the empty array. So it will just be true, which means empty sequence is the first, because empty sequence is the first 0 elements in the Fibonacci sequence. So that's okay. What about IA2 over here? IA2, it is indeed the first elements in the Fibonacci sequence, right? So this is also true. Okay, what about the case for IA3? You can see it has only size 1. That means it must be the first elements in the Fibonacci sequence. In this case, 2 is not equal to 1, so it's false. Okay, hopefully you get an idea. Okay, let's go further. So now over here, what about IA4? In this case, we got an array of size 2, in which case first elements, second elements, so true. Okay, let's go further. So now you should be able to judge that because the first element here, the first element over here, the first element here is not 1. And the second element is over here is not 1, so it's false. Okay, easy. Okay, so now what about this one? This one here is kind of interesting. Okay, I can tell you that to mislead you. Actually, you can see 4 over here is equal to 2 plus 2. 6 over here is equal to 2 plus 4. And 10 over here is equal to 4 plus 6. It seems like the same pattern as what we did for starting from the third element over here in the Fibonacci sequence, right? But after all, it is not a Fibonacci sequence because the beginning two elements over here, 2 and 2. 2 is not equal to 1. 2 is not equal to 1. So overall, it's false. Still, okay? Now, the last one over there looks promising because you can see first element is 1, second element is 1, and now 2 is equal to 1 plus 1, and 3 is equal to 1 plus 2. 5 is equal to 2 plus 3, so this is true. Okay, so now hopefully you get a feel. So what does it really mean when you give an array of certain size? It's really indeed the first IA.length elements in the Fibonacci sequence. Okay, that means the array itself might be empty, or the array itself might be of size 1, in which case it must be 1. And the array can be of size 2, in which case the first two elements must be 1 and 1. Okay, and the array can also be of size larger than or equal to 2, in which case, starting from the third element, it must follow the pattern that we talk about for Fibonacci sequence, right? 2 is equal to 1 plus 1, and also 3 over here is equal to 2 plus 1, and 5 over here is equal to 3 plus 2, right? So these are the three cases we have to deal with to solve this problem over here. Okay, so the special cases would be 0, the length 0, length 1, and length 2. Okay, so now let's program this in Java. Okay, again, hopefully the iPad illustration makes sense to you conceptually, and now it's only a matter of translating the concept and make sure they're consistent in the Java coding. And of course, that's really up to lots of practice from your side. Okay, so now let's go for here. Let's now do this. Okay, so now what we will do is, okay, so for just clarity, I don't want to write at IA the length always. I can simply put length over here is assigned to IA dot length. Okay, I just want to put it. It's an intermediate variable. So whenever I want to use IA dot length, I can just write length. Okay, and then I'm gonna have some Boolean result. Boolean result. Okay, so now I'll just put it here. Okay, now what should it be? I know that if length is equal to 0, that means it's simply just going to be true, right? So I can say if length is equal to 0, so which would be this empty array over the case over here. I can say it's simply just true. I can say result is assigned to true. Of course, eventually I'm going to return the result. Okay, and then else we're gonna also assign some value to result, and over here, otherwise what we will do is, what does it really mean when we have over here? Because we know that IA the length is always larger than or equal to 0, it cannot have negative size array. That's simply not physically possible. Okay, so this means when length is equal to 0, we will go for this branch. So if we reach the else branch, that means length is strictly larger than 0. Or length is larger than or equal to 1, right? So that means we got at least one element. In which case we say that if you got at least one element in your array, and for that to be a Fibonacci sequence, the first element must be just 1. And 1, and also 1 over here, right? In all the cases. So now we can reassign, first of all, result is just equal to IA at position 0 is equal to 1. Okay, just that. Okay, the first elements. Okay, so now what I would say is, again, so now I want to do one more. Over here, notice that I cannot say something like, be careful. IA 1 is assigned to be 1. So I'm saying that the first two elements are simply just 1 and 1. This will be a trouble. This might cause, this may or may not cause array index out of bound exception at the runtime for the following reason. Let's say over here, if IA is an array of size 1, let's say, in that case, length would be just 1. And 1 equals 0 will be false, which means we go to the else branch. And then the IA, the length is simply 1. That means the only valid index we can put would be index 0. And index 1 is simply not there, right? Because for an array of size 1, the only valid index is 0, not 1. Okay, so this will be troublesome. So that's why we simply just don't put it here. What we will put is over here. We can try to do another special case. We can say if we try to protect the index we're trying to use. So if length is larger than 1, okay? So now we used to say length is larger than or equal to 1. We now say if it's strictly larger than 1. That means it's larger than or equal to 2. Larger than or equal to 2. So now in that case, what we will do is we will try to go a little bit further. If that's larger than or equal to 2, which can be either this case over here, exactly 2, or strictly larger than 2, right? In that case, both elements in the first, both the first and second elements must be 1 and 1. Okay, I can say result is assigned to whatever result it was from before over here, and then result is equal to result and IA at position 1 equals 1. Okay, and now what we will do is we have done in the case of the array of size only 2, we should be able to just exit and then just return whatever result it is. In the case where the array size is strictly larger than 2, we still have to run a for loop starting from index 2, right? Okay, so let's try that. So we can say for integer I is assigned to 2, I is less than, you can say length, or you can say IA dot length. Okay, just say IA dot length if you like. Okay, and then I plus plus. Okay, over here, and then we can say again, we can just do different versions over here, right? Version 1, result, okay, just for you, result is assigned to result, and okay, what should we do? IA at position I is equal to the sum of the previous 2 elements, IA at position I minus 1 plus IA at position I minus 2. Okay, that's version 1. Version 1, which is correct because of accumulation of result. Okay, this one works, and then let's see another version over here which wouldn't work. I will eventually run the version 3. Version 1 does work. Okay, version 1 over here, I'm just commenting it out. Let's say version 2. Again, you should really review what we said about version 1, 2, and 3 for its arithmetic sequence. You can see we got version 1, version 2 being incorrect, and version 3, right? And also, we got all multiples of 5 over there. All multiples of 5 is over here. This method over here, you can see we also got the 3 versions there. Okay, the second version without accumulation is always wrong. Okay, I'll show you one more counter example. Okay, after I finish the coding. Let me go back here. Is Fibonacci sequence over here? I would say version 2. Incorrect because no accumulation. Because of no accumulation of the result. So now I can say for integer I is assigned to 2, I is less than IA dot length, and then I plus plus. What I will do is, rather than having this, I'm gonna have this and then take out the accumulation part. And why is this wrong? Let me give you an example to show you how it can go wrong. Okay, let's try this. Okay, let me just give you one example where it can go wrong. Why version 2 is incorrect. Okay, let's have a look at one sequence over here. Let's say we have IA over here, which is pointing to over here. Okay, let's say we have a longer sequence over here. Okay, let's try to do a little bit more than what we did before. So let's say 0, 1, 2, 3, 4, 5, 6, 7. Let's say we got 1 and 1. Okay, no problem about it. And then let's say we got 2 over here. And then we got, let's say we got 2, and then we got 3, and then I got 4 over here, and then I got 7, and then I got 10, and then I got 17. Okay, now according to the version number 2 over here, okay, let's see what's going to happen. Okay, just be careful. So now we know that, first of all, first element is 1, second element is 1, so that's something we will do, right? You can say result is going to be, first of all, IA at position 0 is 1 over here, and also because size is larger than 1, Also, result is accumulated to IA at position 1 is also 1. That's fine so far. And then we'll run this loop over here for version 2. You can see result is reassigned in every iteration. Okay, so let's see what's gonna happen. Okay, so now for the first iteration, 2 is equal to 1 plus 1. Good. Okay, for the second iteration over here, okay, 3 is not equal to, 3 is equal to 1 plus 2. That's also fine. Okay, in the third iteration over here, 4 is also equal to 3 plus 2. That's also fine. Okay, and then, so let's say 3 is equal to 2 plus 1, 4 is, no, actually, let me just undo. Sorry, I got a little bit confused myself. Let me do it again. In the first iteration, 2 is equal to 1 plus 1, no problem. In the second iteration, 3 is equal to 2 plus 1, that's also no problem. Okay, in the third iteration over here, 4 is not equal to 3 plus 2, right? 5 is not equal to 4. So this is not good. So this, at the end of the third iteration, we're going to have this expression over here being false. And then we're going to assign false to result. Okay? However, the result itself cannot affect about the state condition over here. So now that means we'll keep going. Okay? So that means we'll go to the next iteration over there. And then we'll go to the fourth iteration over here. You can see that 7 is indeed equal to 4 plus 3. In that case, result will be reassigned to true again, right? So that means at the end of the fourth iteration, because this expression over here, because 7 is equal to 4 plus 3, in that case, result will be reassigned to true. And then you can see that, so we kind of forget. So this result over here is forgotten. Just wipe out. Okay, which is really bad. Let's go on. And then we go to the iteration number 5 over here. And now 10 is not equal to 7 plus 4, right? Because 4 plus 7, 11, not equal to 10. Okay, that's the second time we actually find a second witness of a violation. So that means at the end of the iteration number 5, we're going to reassign the result to be false again. And again, we go to, we don't actually exit the loop. We don't, because the result, it cannot affect what the state condition is. It's not part of it. So now we go to the last iteration number 6. Okay, in that case, 17 is indeed equal to 7 plus 10. So now its result is reassigned to true again, right? So now it's reassigned to true again. So that means we have forgotten about the result the second time, right? So now you can see forgotten. So it's going to give us some false result, some wrong result. In which case, it's simply going to say result. It would just be corresponding to whether the first checking is actually succeed or not, either true or false. And in this case, even though the last condition, the last iteration is true, but we got 2 previous false, right? So which is not good. Okay, so that's why the version 2 is simply wrong. Okay, hopefully we have illustrated this kind of pattern over here for version 2 three times already in this tutorial series. Hopefully you really see why version 2 without the accumulation and without the state condition involvement is really wrong. Okay, so now let's go to version 3. Correct? Because as soon as exit from the loop, as soon as result becomes false. Okay, so now what we will do is we'll say for integer I is assigned to 2. Now we'll get result involved in the state condition ia.length over here I plus plus. Okay, so now result is over here. Did I do anything wrong? No, it's okay. Oh, I is less than ia.length. Okay, and then we'll say the same as what we did for version 2. But now you can see the extension is the state condition over here in version 3 involves the result over here. So that means this one over here, okay, where 4 is not equal to 3 plus 2. This is the first time we got the false for the result, which means as soon as result is really reassigned to false, and then when we check the loop header again, result being false is going to cause the entire conjunction to be false. That means we exit from the loop. Okay, so this is going to be correct. Okay. So now let's execute the code. Before I do that, I just want to do a little bit more annotation for you over here. Okay, now I want to do a little bit annotation over here. So now, in the case of empty array, we just return true. Okay, because result is assigned to true, and then we bypass the else branch and just return the result. Okay, and then over here, in the case of array of length 1, in that case we bypass the if statement body and return whether or not IA0 is 1. It's only that, right? It's only that. So in the case where we only got one element in the array, so we only get either 1 is 1, so that'll be true. In this case, 2 is not 1, so that's false. Okay. Okay, one more. So now over here, what we'll do is about a for loop. Okay, let me just go to version 3 over here and show you. Okay, so now we'll say in the case of array of length 2, we bypass the loop body and return whether or not IA0 and IA1 are both 1. So what does that mean? That means over here you can say I is initialized to be 2. If IA, the length, is simply 2, we got 2 less than 2, which is false, which means we do not even bother to execute the very first iteration of the loop. We just bypass, and that means the truthfulness for the result to be returned only depends on whether the IA at 1 is 1 and also IA at 0 is 1. So you should really try to study the code structure over here. Itself is not that many lines of code. It's just that I give you many versions and many comments for you to study. So you should really try to understand the comments first and then try to put them elsewhere to really see exactly what the coding is trying to tell you. Okay, so now let's go to utilities tester over here. So now we will test it. Okay, so now that's what we're going to do. We got IA 19 to 27. Okay, so now let's test it. Utilities tester. So we got 3 versions. Version 1 and version 3 will work. Version 2 does not work. Okay, let's now go to over here. So now let's say the first one, IA19, which is empty, and empty should be true. Okay, what about IA20? In this case, it's only one element there, so that should be 1. That should be true. Okay, I didn't really. Also, you can see IA24 over here, which is 2. We'll get there. Okay, and then we got 1, 1. That's right. True. Also, we got 1, 1, 2, which is also true. Okay, we got 1, 1, 2, 3, 5, 8, exactly Fibonacci sequence, true. And also now only one array of size, array of size 1, but the first element is not 1, so false. And also, not both elements are 1, so that's false. And over here, even though the first 2 elements are 1, you can see this one is okay. Okay, this one is fine. So now this one is wrong because 4 is not equal to 2 plus 3, right? So that's the witness for violation. Okay, that's false. Okay, similarly, so now you can see that this one is interesting. So now, but of course, it will be false already because the first 2 elements are not 1s, right? That should be false. But you can see that 6 is equal to 3 plus 3, 9 is equal to 6 plus 3, 15 is equal to 6 plus 9, and 24 is equal to 9 plus 15, and 39 is equal to 15 plus 24. So you can see that it was really crucial that in the code we really got these two conditions over here to say IA at position 0 should be equal to 1, and also accumulate the result to say IA1 at position 1 must be 1 as well. Okay, you should really study the code structure over here and try to understand fully and try to see why we got the 3 versions over here, and then version 1 and version 2 work, but not, version 1 and version 3 worked, but not version 2. For the reason that I illustrated in this example over here. Okay, it's really important for you to see why it is not the case that it is correct.